Hey everyone, welcome back. Today we are going to be working on solving logarithmic equations by using the properties of logarithms. Just so you know, a logarithmic equation is any equation that has a log in it. So it might have more than one log, it might have a log on each side. Depending on what it looks like will dictate how you have to solve the equation. Remember, whenever the instructions say to solve, the goal is to get x by itself. But before you can do that, you have to know your properties of logarithms. There's 3 different properties to learn: the product property, quotient property, and power property. So the product property, it basically tells you that if you have the product of two numbers, x times y, inside of a log, you can split that up into two separate logs. So it's saying the log with the base of b of x added to the log with the base of b of y would be equal to the log base b of x times y. So typically in a problem where you're solving, you're going to see it as log base b of x plus log base b of y, and you'll have to combine it together to be log base b of x times y. Notice that the base doesn't change. The base is the same throughout the entire problem. It's base b. And it might help you to remember that adding, when you have two logs added together, you don't add together the x and the y. You kind of think about that turned a little bit, plus sign. It could kind of look like a times in between the x and the y. Next is the quotient property. We have log base b of x divided by y. For that, you could split it up by doing the log base b of the numerator x minus the log with the base of b of the denominator y. The way you can remember that one is that the minus sign kind of looks like the divided sign or the fraction bar here in between the x and the y. So again, typically if you're solving a problem, you'll have two separate logs that you're trying to combine together. And if the two logs have a minus sign between them, that's when you're going to divide to combine them together. Last but not least, you have the power property. So if you have a log base b of x, but that x is raised to the power of y, the power property tells us that you can bring that power down into the front of the log. Because logs have to do with exponents, you can bring it out in front of the log. So it kind of cancels out the log. This number or coefficient in front of the log will have to be brought up as a power. Okay, depending on whether there is a log on both sides of the equation or a log only on one side of the equation, that's going to tell you what to do. If it's on both sides, you just use the one-to-one property, similar to with exponents, when we got the bases the same and then dropped the bases and set the exponents equal. It's similar to that. Whereas if there's only a log on one side, you're going to have to change it to exponential form. Let's take a look first at this example 4. Solve this equation: log base 6 of x plus log base 6 of x minus 9 equals 2. This falls under the category of there's only a log on one side, because both of these are on the same side of the equal sign. Now, in order to solve it, the first thing you have to do is combine these together. Anytime you have more than one log, you have to put them together first. So since they're on the same side, we're going to combine these together. They're like terms because they're log base 6. In order to combine them together, since they have a plus sign between them, you're going to multiply what's inside the log. So it's going to stay as log base 6, but inside of here, you're going to multiply x by x minus 9. On the other side, you're going to keep the 2, just bring it down. Now, since there's a log only on one side, we're going to change it to exponent form. So we'll use base, answer, exponent. Remember, bay. Logs are bay. So we go base is 6, the exponent is 2, and the answer is x times x minus 9. Simplify this. 6 squared gets you 36. X times x minus 9 is x squared minus 9x. Now to solve this, I'm going to put it into standard form since it's a quadratic. So I have 0 equals x squared minus 9x minus 36. Then I have 4 options to solve a quadratic. I could do factoring, graphing, completing the square, or quadratic formula. I always try factoring first. Can I think of any two numbers that multiply up to AC negative 36 and they add up to the B value negative 9? Let's think about it. It's not going to be 1 and 36. 2 and 18 isn't going to work. How about 3 and 12? That'll work. I need it to multiply up to a negative 9, so I'm going to go positive 3 times negative 12. That'll add up to negative 9. It'll multiply up to negative 36. So my factors are x plus 3 and x minus 12. After you factor it out, you use the zero product property. That's where you separate your two factors into two separate equations, both equal to 0 separately. And then you solve each equation on its own. The first equation solves to give you x equals negative 3. The second equation solves to give you x equals 12. Before you finalize these answers, you have to go back and check your work. Because the domain of a log is only x can only be greater than 0, you have to make sure that whatever's inside the log will always remain greater than 0. So first let's check with negative 3. If x is negative 3, that's going to cause this log to be log base 6 of negative 3. That's not possible. If you try typing it in your calculator, it's going to say error domain. The domain of a log has to be positive numbers. So this answer is an extraneous root. Now let's check x equals 12. Log base 6 of 12, that's totally fine. That's a positive inside the log. Double check the other one. Log base 6 of 12 minus 9. Is 12 minus 9 still positive or greater than 0? Yes. So that answer is perfectly fine. You can actually plug in 12 for all the x's and make sure that it works out. But really what you're looking for is just to make sure that what's inside the log remains positive. Okay, let's do one more together before you go do any by yourself, because we haven't seen one with a log on both sides yet. So let's take a look at this. First things first, I noticed that the side on the left has a coefficient of 2. That's where you're going to have to use your power property, where you bring up the 2 as a power first, instead of leaving it as a coefficient. On the right side, I noticed that I have two logs and they're added together. Remember, adding, I would have to use my product property. They're like terms, they're both log base 7, but to combine them together, I do log base 7 and I multiply 27 times 3. Okay, so to simplify this, you're going to do log base 7 of x squared equals log base 7 of 81. Now, since they're both log base 7 on both sides, and you have a log on both sides with the same base, this is where you can use the one-to-one property. Similar to how if you're doing an exponential equation and you ended up with something like 2 to the x equals 2 to the 3x plus 4, you could drop those bases and set the exponents equal. It works the exact same way with a log. If you have a log with the same base on both sides, you can drop the logs and set what's inside of them equal. So now we end up with the equation x squared equals 81, and we know that in order to simplify that and get x by itself, we're going to square root it. Whenever we square root both sides, we do plus or minus in front of the side with the number. So we get x equals plus or minus 9. Now double check this. If we were to plug in negative 9 here for x, that's going to cause a negative inside of a log. So our answer actually cannot be negative 9. That's an extraneous root. Our answer can only be x equals positive 9, because that would cause a positive inside of the log. Okay, there's one more practice problem if you'd like to try it on your own. I'll show you the answer to that. Otherwise, you're welcome to just go ahead and start working on the EDIA problems because they will help you practice the same stuff. On the EDIA, it also includes more practice for goal 8, which we aren't going to learn until tomorrow. So just get it started. You should be able to do the first 5 problems. But if you have questions on them as you try to look at the explanations, but you can also ask more questions in class tomorrow. Here's the answer to that problem. If you look at it, this one actually should not be -9. It should only be +4 because -9 would cause a domain error. All right, that about wraps it up. I look forward to seeing you guys again tomorrow and working on more logs and exponentials. See you then. Bye.